Where are the thumbs up, guys? Many of them. We should all be excited. We're doing maths. Anyway, good evening all, and welcome once again to another lesson. So in today's lesson, we are going to be looking at financial mathematics, but the specific topics that we want to look at, which is effective interest rate or effective interest. We also want to look at under annuities, future value. So just a quick reminder, you guys are welcome to disturb me at any point as I am teaching in this lesson, especially when you have something which you do not understand. So I like questions a lot. They make me happy. So whenever you feel like you are confused, please unmute yourself or raise your hand. I'm going to recognize you, and then you will ask your question. So remember, these lessons are aimed at making you to understand. So you shouldn't come in confusion and leave in confusion. Okay. So let us quickly start this session by quickly looking at something that is called effective interest. We'll get into annuities / future value a bit later. So there's an important formula which you need to remember whenever you see the word effective interest. You will see it in the exam or in questions, but let's quickly deal with that. So whenever you see the word effective interest, for the purposes of your subject, what should come to your mind is the formula below. Why does my font look big? Okay, let's fix this font. So what should come to your mind is this formula here, which is 1 plus I EF. So this is EFF, and this will be equal to 1 plus I divided by M all to the power of M. This is the formula which should come to our mind, all of us guys, whenever we see the term effective interest rate. So let's put in the rate here. So as a starting point, we quickly need to define what are these here. What is the IFF? So if you remember that IEFF is what we call the effective interest rate. So whenever they are saying calculate the effective interest rate, they are looking for IEFF, the effective interest rate. And then if you look carefully, we have another parameter which we need to look at, which is I. And usually this I here, we usually put an M at the top, but that M doesn't mean exponent, okay? So that M there is not an exponent. And you should look at the M which I'm pointing to and not think of the wrong M. It is the M that is on top of the I. So they usually put in an M there. And that is not an exponent. That's very important for you to note, okay? So that IM is what is called the nominal interest rate. So it is called the nominal interest rate. So this is one of the important parameters which you need to remember whenever you see the word effective interest in a problem. Another parameter that we need to look at is M. And if you guys remember M, we defined it previously, it is the compounding period. And if you are somehow confused of what a compounding period is, I would advise you to go and watch the lesson we did on compound interest. We explained all the different possible cases for M. But just to make sure that we are all aligned, I'm just going to give you a quick summary before we dive into problems. So this summary will help you whenever you're looking at compounding. So if you see the term quarterly, that term, what it means is that your M will be 4. And that in turn means that your interest, you will be dividing it by 4, whatever the nominal interest is. Where M is 4, that would be the compounding period. When they say monthly, I just want you to remember that in a year, there's 12 months. When they say monthly, how many months are there in a year? That will be 12. So our compounding period will be 12. And wherever we have I, we will take that I and divide it by 12. In a case where they use the term monthly. And then they will at times use the term biannually. And if you guys remember, biannually means twice a year. So our compounding period will be 2, which means wherever we see our I, we will divide it by 2. That would be when they use the term biannually. But equally so, they can use the term, guys, semi-annually. And semi-annually, semi is half a year. So this is just the same as biannual. So our compounding period would be 2. And wherever we see I, we divide it by 2. We are now missing probably the last one, but there's many ways they can phrase this. So let's look at when they say daily. If we somehow get a question where they say our interest is compounding daily, we should know that our compounding period, how many days do we have in a year? We have 365 days. So wherever we see our interest, we'll divide it by 365. So this is what we would have, guys, and there's many other cases that we can look into, especially when we are dealing with the compounding period. So all what we are required to do is, if we are required to find the effective interest, we will use this important formula of ours, which is here. Do you guys follow? So here, all what I was doing was just touching on the compounding period. Nothing deep. Let's go and have a look at how do we use what we are doing here in a question. So let's have a look at this question, guys. We'll call it question 1. I need someone in the meeting to read for us. Any volunteer, please go ahead. We should be active. You can unmute and please read the question for us. Any volunteer, guys? Just give it a shot. You're just reading what you see and that's it. I see a hand from Ayanda. You can go ahead.
You have a choice of three banks at which you are going to invest a sum of money. Bank A, 12% compounded semi-annually. Bank B, 11.9% compounded quarterly. And Bank C, 12.1% compounded annually. Use effective interest rates to determine which option will be the best.
Okay, thank you for that. So guys, if you look at this question here, you have 3 banks. They are offering you an interest rate. Do you all see that it's very close to each other? 12%, 11.9, 12.1. Do you all see that it's very close to one another? Now the question is, which one is a better deal? Before we do the calculation, do we have people who want to make a guess? So which one is the better deal here? Guys, any volunteer? I see from Ayanda.
I think the better option is Bank B.
Bank B. Okay. So we have one person who's saying Bank B. Anyone else is looking at this and saying, okay, I haven't done the maths, but I'm going to guess which one here is a better deal? Which one here is going to give me more money? Anyone else, guys? Take your guess. If you get it right, it's a sign that you should play Lotto. Anyone else? Okay. So because there's no one else, we'll just stick to the guess of Ayanda and we'll see if that works. So the problem here is if you look at these values, they are different. So another person who's looking at this would just say, I'm tempted to say that the better option here might be Bank C because I see a bigger rate. Someone else can look at this problem and just say that 12.1% is bigger than 11.9 and it is bigger than 12%. But how do we equalize this? So the effective interest rate helps us to be able to put the comparison at the same level. That is what the effective interest will allow us to do. So let's start by option A. So remember that the effective interest rate will just be the interest per annum. Maybe let me say that. So EEFF, all what this will tell you is that this will be the effective interest. It is the effective interest per year. This is what the IEFF will be. So it means when we find the effective interest rate, we are going to remove the semi-annually. We are converting it from semi-annually to per year, which is annual. We will be converting from quarterly, that interest from compounding quarterly to compounding annually. That is what we will be doing. So let's start by looking at option A. So for option A, guys, what is the compounding period? So remember our formula is 1 plus I EFF equals 1 plus I M divided by M all to the power of M. So for option A, what is our M, the compounding period? Anyone? Anyone, guys? I see a hand from Ayanda. You can go ahead.
I think it's 2.
So they said semi-annually for Bank A. So maybe let me just put Bank A. So if you look at the compounding period, they said semi-annually, which will be 2. And if you look at the interest rate, whatever which we are given is always the nominal interest. So our IM will be 12%. And they told us use the effective interest, meaning what we are looking for is the effective interest. So we are now in a position to go and find the effective interest because all what you need is the compounding period and the nominal interest. So we can now go and say 1 plus I EFF equals 1 plus our interest for Bank A is 12%. And this will be divided by 2 because it is semi-annually, all to the power of 2. And remember that, guys, we are solving for I effective, the effective interest rate. So if you look carefully, the effective interest rate, all what is left for me to get it is I need to move this 1 to the other side. So that means what I have is 1 plus 12% divided by 2 to the power of 2 minus 1. Anyone, guys, please give me the answer. What do you get when you punch this on your calculator? What do you get as your effective interest rate? I see a hand from Tumelo.
Zero
Zero
comma nine
comma 1236.
It is
1236.
0,1236. And when you put this as a percent, you get 12.36%. Do you guys understand? Remember, to convert to a percent, you just multiply by 100, okay? That is the effective interest for Bank 1. Let's go to not Bank 1, but Bank B. I see, Tumelo, you have your hand up. Do you have a question for me?
no sir. No sir.
Okay, no problem. Look for the hand down there and click it. Thanks. So let's have a look at Bank B, guys. What is the compounding period? What is M equal to? Anyone? They said quarterly. I see a hand from, let us take Susan. We've never heard from them. You can go ahead.
The compounding period is equal to 4.
Okay, it is equal to 4 because they said quarterly, guys. And what else are we given? The nominal interest. What is the nominal interest, guys? Anyone? The hands should be going up, guys. You should be looking at my screen. That is where your focus is at. I see a hand from Ayanda. You can go ahead.
It's 11.9%.
11.9%. Remember, guys, I'm going to remind you because I care about you. That there is not a power. You don't go and insert the N, the M there. You will get the answer wrong. It is just a notation. Okay. So now we're in a position where we can use our formula and just plug back. So we'll have 1 plus I EFF equals 1 plus our interest rate is 11.9% divided by 4. And this is all to the power of 4. So remember, we're solving for the effective interest rate. So our IEFF will be what we have here. So let's copy that, paste it here, and put in -1 at the end. Anyone, guys, who's using their calculator, please give us the answer. We should all get our calculators and put them next to us. What is the answer?
It is 12.44%.
12.44%. Thank you. So we are left with Bank C now. Then we are going to be able to tell our friend which one is a better deal here. So let's go to Bank C. So from Bank C, guys, what is our compounding period? Hmm.
Once in a year, sir. Oh,
So they said annually. So for annually, how many annuals are there in one annual? That is interesting English. But what is our M, guys? That should give you an idea of the answer.
once in a year.
It is 1 on point. So maybe let's add that, guys. So annually, when they use the term and they say this is compounded annually, you should remember that what that means is that M is 1 and your interest, you will divide it by 1. Essentially, you do nothing to it. Okay. So let's go ahead and put in our nominal interest, which is 12.1%. So we can go and use our formula. Just plug in and see what we obtain. So I'm going to have 1 plus I EFF equals 1 plus 12.1%. And this is all to the power of 1. So if you look carefully, all what I need to do is to transpose the 1, and then that 1 will actually cancel with this 1. So my effective interest rate, IEFF, for bank number C will be 12.1%. So the effective interest rate allows us to compare things that were in different periods at the same level, guys. That is what it allows us to do. So now that we have done this, which one of these is the better deal here, guys? Anyone looking at this, which one is the better deal here? I see a hand from, I think, Ayanda.
So I think it's both Bank A and Bank B, because for Bank A, when you round up 12.36, it's going to turn to 12.4. But then for Bank B, if you also round it up, it's still, I mean, if you round it down, it's 12.4 as well.
Okay. So the one which is a better deal is very clear. The other one you must round up, the other one you must round down for them to be equal. So it means the one you are taking down is the better one, isn't it? Because you need to take it down for it to match the other one. Does it make sense? Because
No,
all of
I
them,
understand.
you don't understand. Okay. So you said for bank A, which is 12.36, if we round it up, we get 12.4, isn't it?
Yes, sir.
Awesome. And then you said for bank B, if we choose to round it down, we get 12.4, isn't it?
Yes.
And I'm saying bank B would be better because you need to take it down for it to be equal to the one you take up. Or, just in simple terms, we can just say, we can see that the 12s are the same. So we have 12, 12, and 12 for all of them. Where is the other 12? Here's the other 12. So what then is the different is what comes after the 12. 36, 44, and 1. So which one is bigger? Is it bank A? Is it B? Is it C?
B.
Bank B. So I should be smiling. So if you were advising someone as a person who's doing pure maths, you would say go for bank B. Bank B is a better deal. And when they say, how do you know that? You will say, I did pure maths. I understand effective interest rate. We need to calculate the effective rate for all of them. That is how we are going to be able to compare them. If you look at the problem initially, you would be tempted to say, oh, but bank B is 11.9, but it is compounded quarterly. When you even them out, you see that bank B is the better one. But a person who's doing math lit, yeah, I'm not sure what they were going to choose. They were not going to choose B. Anyway, guys, I see a hand from Tori, so you can go ahead.
So what's the difference between nominal interest rate and effective interest rate?
So the difference is your nominal interest rate has different compounding periods. Okay, so it can be compounded semi-annually, quarterly, and whatever. Your effective interest rate takes that nominal interest and it makes it to be an annual interest. So we're looking at if this interest we're saying it was compounded per year, how much would we get? Not quarterly, not semi-quarterly. So essentially we are taking the different compounding periods to get the effective. The effective is interest that is compounded per year. Do you understand?
Yes, I do. Thank you.
So if I may add on that, you guys must go to your friends and be able to explain. So the reason why we couldn't make a comparison by just looking here was because the compounding periods are different. So Bank A says 12% compounded semi-annually. What does that mean? If I was explaining to a child who's 5, I was going to say to them, Bank A says, I'm going to give you 12%, but that 12% is going to increase semi-annually, meaning at the end of June, I am going to, essentially, I'm going to give you 12% in total, but you are going to get that half yearly. And then Bank B says something else, Bank C says something else. So we are having difficulties with those compounding periods. But the effective interest does is it takes the interest and it makes it to be an interest per year. The interest at the end of the year, what would it be? So that is why we went to Bank A and we said, we see you say semi-annually, but we want to know if we were making this interest to be annual, how much do I get as the effective interest annually? That is why we have to calculate the effective interest for all. Then we can compare them. Does that make sense, guys? It is very important that you understand that. Yep, you are welcome to give me a thumbs up. And if you don't understand, please make sure that you do unmute. Guys, you are here to learn. So you should go to your friend and say, do you know effective interest rate? And they say, I've seen it in the maths textbook, but I don't know what it is. You should sit down with them and say, you know, what we do is we take the nominal interest, which is what we would be given. They would say compounded semi-annually, quarterly, daily, monthly, whatever. And we are trying to find the effective interest if we were working with a period of just a year, no compounded by annually or anything, just a year. So if they want us to compare, we want to take all the interests and make them to be per year. Because when they are now per year, our eyes will be clear. We are taking the bigger one. That is the better deal. So here our conclusion, guys, is you're welcome to ask a question. I can tell that someone is unmuted. I think it's Ayan that you have a question for me. Okay, no problem. So if you look at this problem here, Bank B is the better deal, or has a better deal. I hope you guys understand. So with that said, let's move to the next question. So let's have a look at this question, guys. That is our question 2. And I need someone in the meeting to read this for us. We are practicing reading in the exam, guys. Any volunteer, please go ahead. And thank you in advance.
Convert a
Go
nominal
ahead, just unmute yourself.
interest rate of 7% per annum, compounded semi-annually. Convert a nominal interest rate of 7% per annum, compounded annually, semi-annually, to the effective annual interest rate.
On point. Thank you for that. So what we need to understand, guys, is when we look here, they are saying convert the nominal interest rate of 7% to the effective annual interest rate. So if you look at this question, what are we looking for? If you read between the lines, it becomes obvious. Anyone who wants to take this, what are we looking for, guys? Okay, I'm going to give it away. We are looking for IEFF, which is the effective annual interest rate. So what is the most important formula which we need to remember here? The formula is 1 plus I EFF equals 1 plus IM divided by m all to the power of m. So now my question to you guys is, what is m equal to? Read the statement, and I need someone who has not answered today to raise their hand. I see a hand from Lebuhang. What is our m equal to?
Twice in a year.
Twice in a year. So should I write m is twice in a year? Yeah, you can unmute. I see Lebuhang, you still have your hand up. Go ahead. Give it a second punch. Should I write m is twice a year? But that is a joke, but you can come in. Just click the unmute button.
Oh, sir, it's 2 months, sir.
No, it is not 2 months. It is supposed to be, so the m you need to give me the value. So should I write 2 months?
I said this one is dribbling me straight, but it's only 2 months, value.
2.
So you just say 2, not 2 months, or you see, yeah. So why is it 2, Lebohang?
Because it's semi-annually.
Okay, no problem. So you should say thank you, Lebohang. She took it for you. Because it is semi-annually, so there's 2 semi-annuals in 1 year, isn't it? Semi-annual means half a year, guys. How many half years are there in 1 year?
2, sir.
Did I hear 4?
Oh,
Nice. Okay. Yeah, it happened. So we have M is 2 here. And then now, what is the nominal interest rate, guys? Should be obvious. Convert that. It is 7%, isn't it? So let's go and find the effective interest rate. Very easy questions, guys. You should all take the marks because they belong to you. So we will have 1 plus our I, EFF. This will be equal to 1 plus our interest will be 7% divided by 2 all to the power of 2. Remember, we are looking for IEFF. So look for EFF, guys. So IEFF will be 1 plus 7% divided by 2 all to the power of 2 minus 1. What is the answer which you are getting, guys? Okay, please give it a shot again. I think it's Zingiwe. Okay.
0,07.
0,07 what?
1.
1. Okay. What is this when we make it percent, guys? Gonna be 7.1%. Okay. Right. So that is what we have as our answer. This is what they were looking for. That is the answer. And our teacher would be smiling because they would be so impressed. We are geniuses, are we not? Yep, we are. You guys understand this idea of effective interest rate? I'm going to wrap it up. If you do, give me a thumbs up. And if you are not comfortable giving me a thumbs up, click the unmute button and tell me where is the discomfort, where are we losing you? What is it which you are not understanding? You only have 2 options, guys. There's no in between. It's either you understand or you don't. There's no gray area. And remember, my being here is to make sure you understand. You shouldn't come in here confused and leave confused. I see a hand from Debuko. You can go ahead first. Just check if your mic is unmuted. So look at your phone and click the mic thing. Okay, I'm not sure what happened to Tebuho, but you can go ahead, Ayanda.
So sir, so you know how for simple and compounded they give us a principal amount. Would they ever do that for effective?
What do you mean?
Like, would they ever give us a principal amount and then ask you to use the effective rate to find out what your new amount would be?
Oh, yeah, I see what you're saying. So the short answer is yes, they can, but here's the interesting part. Whether you use the effective rate or you use the nominal rate, you are going to get the same answer. Is that not impressive?
Very impressive.
Very impressive. Guys, all of you should say very impressive, very impressive. But it is impressive. So the answer to your question is if they give you an amount and they say, here's a principal amount, calculate the total, whether you use the effective rate or you use the nominal rate, you will get the same answer. Understood?
Yes, thank you, sir.
Maths is beautiful. Guys, you should go on your status and say, maths is beautiful. And people will start reacting in shock. Teboho, I think you had your hand up. You can go ahead and ask.
You say I understand.
You now understand?
Yes, sir, I raised my hand because I was trying to tell you that I understand.
No problem. Maths is what?
Very impressive.
Beautiful.
Maths is beautiful. The people who are behind you should hear you. They should say, in that phone, they are saying maths is beautiful. That is so awkward. Anyway, maths is awkwardly beautiful. So let's go ahead, guys. Next. All of you should post on your status, maths is beautiful. Someone who doesn't know and they say, how is it beautiful? You should say, relax. It is awkwardly beautiful, they told us today. I'm not sure what that means, but I'm going to say it. It sounds okay to say. Anyway, glad you guys understand the idea of effective interest rate. Very easy marks. We should take all of them. We are not leaving marks for anyone. Right. So done with that, guys. Next, I want to take you and introduce you to annuities. And this is a very nice topic, to be honest. And it is also extremely easy because I'm the one who's going to tell you about it. And also because you are smart. So let's quickly start with annuities. And this topic has a lot of marks, guys. So in annuities, you will remember or you will observe that we have two really important formulas. We have a future value and this we will denote by FV, and we have present value. And this we will denote by PV. These are the two important parts of annuities. So future value, what is happening here? On future value, we need to look for key terms that will help us to know that we are dealing with future value. So let's have a look at these key terms. What are they? So if you see on a problem the term sinking funds, your brain should say what? Future value. And then when you see investment, and they mention regular deposits, once you see them saying we are depositing now and then, and there's the term investment, what should our brain tell us? Future value. Yep. Do we have anyone else who remembers another term that we should not forget? Another one, savings. So once they mention savings, but they also speak about deposits, our brain should tell us what? Future value. And then they also, another keyword we need to look for is retirement. So once we see retirement, annuity, once we see retirement, annuity, I'm missing an I here. Our English teacher would be so displeased with me. How dare you forget the I? Anyway, once we see retirement annuities, our brain should remind us of future value. So these are the key terms that you guys need to make sure that you understand. So present value, I'm just going to put it there at the end. We'll worry about it later. In fact, how do I throw it out of the screen? Delete it. So these are the key terms that you should be looking for in problems that are related to the future value in under annuities. And then what we need to now remember is the important formula. So we now know the terms, but what is the formula that is very important when we are talking about future value annuities, when we are talking investment? The formula is as follows, guys. We cannot afford to forget it. FV is equal to X into, I'll define what the X is. We have 1 plus I all to the power of n minus 1. And all of this is divided by I. Okay, this is what we have. But I usually prefer writing this formula in a way which we are actually used to. And that way is when there's the compounding period. So I'll put that up. So we have 1 plus I divided by m to the power of m times n minus 1. Then divided by I. I, remember, we always divide it by the compounding period. So I like this form. But in the textbook, the way they give it is such that they usually omit the m, but when you plug in the m. So let's have a look at what is what here. So x is the value, or it is the value of the installments. So with these future value problems, what we will be doing is we'll be making regular deposits. We'll be making deposits. So this would be the deposit or installment amount. So remember that with future value, what we are concerned about is actually investment. So we are investing for the future. So when we invest, we are putting in money per period of time, money monthly in the bank, or weekly, or twice, or once after every 2 months, however way we are making the deposits. So X will be that deposit. And then I will be the interest rate. Good guess. And M will be our compounding period, guys. Very important. And N will be the years, which we are putting up our money for. So that is all what we need. And then F, or that FV, we said it's the future value. So that is sorted. So this is the formula that we are going to use for our calculation. It doesn't get more complex than this. Very straightforward. All what we need to understand is what we are looking for. Okay, need you guys to look at this formula carefully. Look at the N there. The N is positive. You'll see when we deal with present value, it's slightly different. So however, your textbook likes making the formula to look like FV. They usually don't include the compounding period, but they include it when they do the calculation. So that often looks a bit confusing. So from your textbook, the formula looks like this, divided by I. And one thing I want to assure you is this is correct. And guess what? And this is also correct. So you choose which one you want to use. As long as when you use this one, you don't forget that at the end of the day, wherever you see that I, you should go and put in I divided by M when you substitute. So that is why I prefer the formula that I wrote, because it is easy. Already the M is there. I will not forget it. Okay, you guys understand? And you will see when we do present value, you should not mix up the formulas. Guys, I believe none of you will see a car and mistaken it for a train. It would be very odd, isn't it? Imagine if you see a car and your brain convinces you that this is a train. You should be concerned. And that is the same thing that should apply to this maths. We shouldn't mix up these formulas because they are not the same. So if you don't see a car and think it is a train, you shouldn't look at the future value formula and think it's the present value and use the wrong formula. If you can't say a motorbike, that is a train or a truck to a motorbike, you shouldn't use the simple interest formula instead of the compounding interest formula. Anyway, let us go to a question so that I help you to understand this, guys. So, I will need one of you to read this for us. And we will start looking for the keywords. Because under annuities, remember I said we have future value and present value. Is this question 4? Well, make it question 3. Yep, any volunteer, guys, please read for us. And thank you.
A sinking fund savings account will be set up by the school. Monthly deposits earning 11.5% per annum compounded monthly will be made. The first payment will be made a month after the bus was purchased. A. Calculate the second-hand value of the bus in 10 years.
Okay. So let's have a look, guys. So here clearly there's what? Deposits being made. But then when we go back to our key terms, we said for us to be sure that it's the future value, if we see sinking funds, we know we are done. If they say savings, investment, we are done. If they say retirement, it is future value. So we need to look for the future value formula. But let's go back and read and quickly outline what we have and understand the problem. So we already highlight some key terms. So we can clearly see that sinking fund, we know it means future value. So when I see that sinking fund, I'm like, okay, I see what is happening here. Your sinking fund mean future value. So it means I need to use that future value formula. So a sinking fund, which is a future value investment, will be set up, and then they say monthly deposits that are earning 11%, 11.5% compounded monthly will be made. And then they say the first payment will be made a month after the bus was purchased. So we need to unpack this. And then the question is now, we need to calculate the second-hand value of the bus in 10 years' time. Any idea, guys, of what is happening here? Let me see. I think I might have cropped my problem here. Just give me a second. I will be with you. Where is my problem? Yeah, so I did crop out my problem, guys. Let's go for the second one. I'll fix this a bit later. So maybe let's leave this one. Let's go for this one. My apologies on that. I'll fix that one. It's cropped. So let's call this question 4. Any volunteer, guys? Give us this one. The first one, number 1. And the other one, I'll just put it on the other side. Any volunteer, please read for us. Anyone, guys?
Calculate the total amount of money saved if Adam pays an amount of 15,000 out of his yearly bonus into a savings account. He makes the payments at the beginning of each year for a period of 10 years. The interest rate is 10% per annum.
On point. Thank you, guys. So what is the key term that you guys picked out here? I need you to go and look for the key term and tell me what are the key terms here that you were able to pick out.
Savings.
On point. So one of the key terms is we can clearly see that Adam is doing some saving there. What is another key term that you see here? So if you look carefully, they say he makes payments at the beginning of each and every year. So the deposits are made, continuously. So we can just say there's what? Continuous deposits. So he's putting money now again and again. Okay, do you guys agree? So this has told us that, okay, it is a future value problem because the savings and he's making deposits into this account. Deposits. Okay, so that tells us that we are looking at a future value problem. And for future value, remember the important formula is x into, I said we are going to do 1. We're going to do 1 plus I to the power of n, but let me use the one that has the compounding period like this. M times n minus 1, and all of this is divided by I divided by m. So we now, guys, need to figure out what is what here. So remember what I said, x, I said it is the regular deposits. So what is x from this problem?
It is 15,000.
It's 15,000. So if you look carefully, we are required to calculate the total amount saved. And remember that I said the future value is whatever amount which we will have at the bank at the end. So this will be total amount in the bank. So that is what the future value is. So by reading the question, we are very clear that we are looking for that. But if you read the statement, you will see that X is 15,000 rands. And what is I, guys? What is the interest offered? It's 11%, isn't it? And this one I'm very interested in. What is the compounding period? Read this carefully, guys.
I think it's 1.
Why is it 1?
Because they say he makes the payments at the beginning of each year, but then it doesn't say anything about it being compounded monthly or quarterly.
Okay, so we can think of the M as 1 because his interest is just growing, what you would call it, per annum. So it is not growing, in another fraction of a period. So if you look at the problem now, what else is missing? N. What is N, guys?
10.
10.
11.
So Okay, so let's quickly dive into that. So someone is saying 10, someone is saying 11. Let's figure out which one is which here. I like it when we get different answers. So the person who's saying 11, why are they saying 11? And the person who's saying 10, why are they saying 10? Let us think together, guys.
At school, at my school, I was taught that when payments are made at the beginning of the, we should add one on the end.
Okay. Yep, I see what you're saying. Someone else? Anyone else who has a different take here, guys? So he's saying he was taught that if they say beginning, you put one. I see a hand from Ayanda. You can go ahead.
So I also wanted to add one, but then I thought that they said you only add one when the bank is loaning you money because they're giving you like 1 month space to like recover before you start paying. But then here they're saying that he's saving money, so he's not owing the bank money, but he's putting in money. So that's why I think you don't add one.
Okay. Thank you for that. Anyone else, guys, who has a different contribution? What are your thoughts? And when you answer these questions and you think of it, in the exam life becomes easy for you because you are easily able to make sense and not make mistakes of this kind. Anyone, before I take over, what are your thoughts? Is it 10 or is it 11? Okay, so let's go ahead, guys. The short answer here is that the answer is going to be N is going to be 11. Sorry, it is going to be 10. And the reason is because here you are investing. So remember, the reason why you add one is a bank. It's like them saying you will not pay for the first month. They actually add that month. So here you are saving. So there's no catch in your saving. Do you understand that?
Yes, I understand.
Yeah. So what you need to remember here is that we are saving. We are not paying back a loan or anything. So when you pay back a loan, it's like even when they say you will start paying after a certain number of months, they actually increase the period. So here we are saving, not borrowing or paying a loan. So the statement of after 1 month, if I choose to invest my money after a month or so, the bank really doesn't charge me that you had the money and you chose to invest it later. So that is why. So let's go ahead, guys, and cook this one. So our future value, which will be the amount at the bank after 10 years, will be this person is putting 15,000 out of their bonus. Let's see if in the future, guys, we're going to make money. Plus 11%, all to the power of, this will be 10 years. So we'll have 10 minus 1. So the compounding period, remember, it is 1. So maybe let me put it here so that you don't think we actually ignored it. So we have 11% divided by 1 to the power of 1 times 10 minus 1, all divided by 11% divided by 1. What is the future value, guys? After 10 years, what is Mr. Adams having in his bank account? Is he rich?
250,830,13 cents.
250,000
50,830,13 cents.
13. So is Mr. Adams very rich, guys? 10 years is putting 15,000 when he gets his bonus, December. He doesn't use his money on things that are disruptive. He doesn't drink alcohol or drink his money. He's taking it, he's put it in the bank, and he gets, after 10 years, 250,000. And now the question for you guys is, what is his profit here? What profit did Mr. Adam get from his investment?
235,808.13 cents.
So you are saying his profit is equal to 200 and what?
35,000
235,000 and
808
830,
comma 13 cents.
13. How did you get that?
I took the future value and minus the initial amount that he invested monthly. He invested on each year.
Yeah, but how much did he invest in total?
150,000.
Yeah, you can go ahead, Tejo. Thanks for that, Ayanda. How much did he invest in total?
150,000.
Yep. So just to correct your answer a bit, I believe, Tejo. So what you should look at is how much did he put in? So Mr. Adams' money, the one that he puts in, or the total amount that he had put in, after 10 years will be 10 times 12, 15,000. Remember, he's putting 15,000 every year. So it means his total amount that he would have put after 10 years would be 150,000. Do you understand?
Yeah.
This is his total investment. So now when we look at profit, we take the difference of what is in the bank at the end of 10 years minus what he collectively put in. So it's 250, 0.13 minus 150,000. Please give me the answer.
100,830,1%.
13. So does it make sense why that answer is a bit not correct?
Yeah.
Yep. So make sure that when they ask you in the exam, when they say profit, you should remember how much did he actually put? 15,000 in 10 years. So 15 times 10, 150. Now he has that amount in the bank. We take out all the money he put in, meaning the interest gave him 100,000 in 10 years. Do you guys see that maybe investing is not bad? It's actually good. So 100,000 average is to plus minus 10,000 a year. That is a lot of money, isn't it? It's a good amount of money. So invest, guys, when you grow up. Let's go to the next question. You guys understand? If you do, give me a thumbs up. And if you don't, please ask. The only thing I like is you understanding. And that is all what makes me happy. When you are able to look at the problem and say, oh, I see the key terms, therefore I know what to do. So let's go to question 5, guys. So we need a volunteer who can read this for us. And I said maths is what? Do we have people who still remember?
Beautiful.
Yep. We can't afford to forget that. Let's read, guys. Maths is beautiful. So let's read here beautifully. Anyone? Anyone, guys? Someone who...
You want to save
Yep, you can go ahead. Let's give it to you.
money to buy a house in 8 years' time. You decide to save 800 at the end of each month in a savings account. The interest on the savings account is 7.8% compounded monthly. How much money will you have saved by the end of 8 years?
Thanks for that. So the first thing that we need to look at, guys, key terms. What are the key terms or terms that are very important as you read here? Anyone, guys? Go ahead.
Savings.
On point. Savings. Very important term here. Savings. What else is important here? I'll give it to you. We have deposits which are made each month. So if you look carefully, you decide to save 800 rands at the end of each month. So each month is a key term because that is when we make our deposits. So we have deposits, consistent deposits, and we have savings. Our brain should tell us what? Future value.
Future.
On point. Once we see these key terms, you will see with present value. And that is why it's very useful for you to write down the key terms. Your brain, after looking at this, it should say to you future value. Here we come. FV. Okay. So now next, once we are here, we should ask ourselves, what are we looking for? Anyone, guys?
We are looking for the future value.
Yep. So they say, how much money will you save? Will you have saved by the end of 8 years? So it looks like they want us to find the money that will be in the bank in the future. So what are we looking for? Very easy. We are looking for the future value. FV. But how do we find the future value? I gave you a formula which I said, guys, is very important. You can't afford to not know it. It is called FV. FV for future value. We have X into 1 plus I divided by the compounding period to the power of compounding times N minus 1 divided by I divided by M. So I need us to pick out what we have now, guys. So I'm going to start first. Remember, X are the deposits which we make. So X is the deposits, the amount which we put in consistently. I'm going to give it to you. It is 800 rands. Someone in the meeting, please give me what I is. You should answer so that you don't sleep, guys.
It is
7.8.
7,8. We are not here to sleep. The marks will sleep. What is M, guys? So you should read and say, oh,
12.
is it compounded monthly? Why is it 12?
They told us that it's compounded monthly and it's 12 months in 1 year.
Oh, genius. Why are you guys not clapping for each other? I'm kidding. Please clap for them. Okay. So M is 12, okay? Because there is 12 months in a year. That is correct. So what is left? We have that. And what is N, guys? You can see our formula is N.
8.
8. So we can now go and calculate our future value because they are asking, how much money are we going to have in the bank, guys? So our future value will be, we are putting in 800 per month in the bank. So we are hustling here. 1 plus our interest rate is 7.8%. We always divide by the compounding period, which will be 12. Then we'll have 12 multiplied by the number of years, which is 8. Then subtract 1. So let me quickly make some space. Subtract 1 like that. And divide by our interest, which is 7.8%. And this should always be divided by 12. What is the future value, guys? How much money are we going to have in the bank? We want to save up for our house. We are getting old. So we put in 800 rands, 8. 8 years later, we want to go to see in the bank how much is there. How much are we going to find? Yep, you can go ahead. Ayanda.
106,167,85.
106,000.
167.
Okay. Oh, 167,
85.
85. So this is what happens, guys. Every month we say, okay, I'm going to put 800 rands in the bank. The bank offered me an interest rate of 7.8. I'm going to do that for straight 8 years. I'm disciplined. 8 years later, when I go in the bank, they say you have 106,167 and 85 cents. Sounds like a lot of money, isn't it? But the question which I am asking myself now is, oh, I see you are giving me this figure. I want to see the profit here. How much money did I actually make? Right. Anyone, guys, wants to guide us? How do we get the profit? Very easy. You can go ahead.
You're going to say your future value minus 800 times 12, and then you're going to times that answer by 8 years. So the 800 times 12 times 8 is 76,800.
Yep, on point. So maybe let's work it out this way. You are correct. So I'm going to look at the invested amount. So how much did we put in total? If you look carefully, it is what she's saying. It is 800. Remember, we're putting the 800 per month and for 8 years. Okay. So what is the total invested amount, guys?
$76,800.
76,800. And then now, when we go and look at profit, this is very easy to work out because it becomes the future value, which is just the total amount in the bank minus what we put in, which is the invested amount. So you are interested on, is the bank giving me enough profit? So the answer will be, you can punch in on your calculator, 106, 167,85 minus 76,800. What do we get, guys, as our profit?
29,367,85.
Can you please repeat?
29,367,85.
Okay. So 5 or 8 years later, the amount we would have accumulated on top of what we put in would be 29,367,85. Is this a good investment, guys? Maybe yes, maybe no. Yeah, I don't know. But it's good enough. Okay, let's move, guys, to the next question. Let me see. With example, let's go to question 6. And before I go here, you guys understand? Where are my thumbs ups? And if you don't feel comfortable giving me a thumbs up, use the mic button and say, I think you are losing me here. So I'm expecting thumbs ups from everyone. A person who can't give me a thumbs up must give me a mic on, because I want to help you to make sure that you understand this. When you go to school on Monday, you should say, give me any annuity problem, future value. I'm going to work it out for you. I think I have an idea of what is going on there. You should have that level of confidence. Because math is what? You guys forgot. Yes, because math is beautiful. So let's go, guys. Next question. That should be number 6. So we need a volunteer who's going to read for us here. Question 6. Anyone?
Jack took out an ordinary annuity for him when he was born. The monthly payment is 200 Rand and interest rate is 10% per annum compounded monthly. Peter's parents started an annuity fund for him when he turned 12 years old. The monthly payment is 800 and interest is 12% per annum compounded monthly. Both Jack and Peter will receive the money from the annuities on their 21st birthday. Will receive more money on their 21st birthday. And B is how much money did each set of parents contribute in total? Express the interest rate as a percentage of the total contribution in each case. What do you conclude from your answer to A to D?
On point. Thank you for that. So here we have 2 families. So they plan for the kids, which is good. Okay. So we have a family of Peter. They are planning for him. And we have a family of Jack. And the parents are planning for him. So the first question is saying, who will receive more money on their 21st birthday? So the first thing that I need us to establish, guys, is the key terms. As you look at this problem here, what are key terms that you picked up? Anyone, guys? Are we all saying we can't see any key term here? I'm going to give it to you, one of them. I see there is annuity. So that says to me, okay, annuity means it's either a future or present value. What else do you see? Because remember, present value is for debt, future value is for investment.
Monthly payment.
Yep, I see they say monthly payment. So that tells me, okay, we are making deposits here. And when you look carefully, they are planning for their 21st. So if they are planning for the 21st, that makes it to be a future one, isn't it, guys? Because what they are doing here is future plans for the kids. So reading at this problem, or reading the problem, I'm not confused of what I should do. It is very clear that we have a future value problem here. The parents, they want to figure out, when these kids turn 21, how much are we going to have in the bank for them? We want to bless them with something. Okay. So now let's start with Peter. Or let's start with Jack, not Peter. So let's have a look at Jack's situation. So we all understand that the future value is what we are looking for. So for Jack, why am I saying Jack's here? Jack. Yep. So for Jack, guys, the interest rate is I. You observe carefully, it is 10%. But what is the compounding period for Jack? Jack is
12.
green. Yep, the compounding period is compounded monthly, so that is 12. And remember our future value formula, it's very easy. Let me put it up so that we are always up to speed with what we are looking for. So future value is x into 1 plus I divided by m to the power of m times n minus 1. And this is always divided by I over m. So we have the I and we have the m. So where is the x now? So for Jack, what is the x, guys?
200.
Are you sure?
Yes.
Okay. So for Jack, the amount they put in monthly is 200 rands. And what is the end, guys? And I need you to tell me why. I'm so excited for this.
21.
Why is it 21?
Well, because his parents have been putting in the money since he was born.
On point. So his parents were investing from when he was born. From when he was born. So remember, both sets of parents are targeting 21. They say 21, we want to make a very big party for him. So his N is 21. So we can go ahead now and figure out what is the future value. So FV for Jack, this will be 200 into 1 plus, we have 10%. And remember, this is compounded monthly, so we'll have 12 times 21 minus 1. And all of this is divided by 10% divided by 12. What is the future value, guys? So we are on question A here. What is the amount that is going to be in the bank for Jack? To see when he's 21, parents don't tell him what is happening. They put in money. So how much is going to be in the bank when he turns 21?
170,290,05.
170,000,
290,05.
So guys, are our parents saving? I wish. Imagine in 3 years' time, you have 170,000. What would you do? I'm not sure. But let's go and have a look at Peter and see what is happening with him. So Peter's parents started a bit late, but do you guys see what they did? They put more money because they started late. So for Peter, we need to figure out what is the I, guys.
12.
12%. And what is the compounding period for Peter? 12. And what is the X, which is the regular deposits for Peter?
800.
800. And what is N for Peter?
9.
9.
Yep. So Peter's parent started when he was 12 and they're chasing 21. So it becomes 21 minus 12, which becomes 9 years. Okay. So we can go ahead now and do our calculation. So our future value will be 800 into 1 plus 12% divided by 12, all to the power of 12 times. The number of years is 9, then minus 1, close the bracket, divided by 12% divided by 12. Guys, what is the future value? So what is Peter getting? Is he getting bigger bucks? Anyone?
154,314,06.
154 and
314,06.
comma 06. So that is what Peter has. So do you guys see that there are consequences to planning late? So Peter's parents are putting more money. In fact, 4 times than what Jack's parents put. But look at the difference in the money. The money is not making sure, isn't it? Yeah, but not too different. So the answer to A is who will receive more money on their 21st birthday? What's the answer, guys?
Take.
Jack.
So Jack will get more money. Okay. So that is what will happen. So we are done with question A. Then let's go and deal with B on the next page, which is how much money did each parent contribute, or did each set of parents contribute? So we want to figure out over the years, how much did these parents put in total into this investment for their children? And that is question B. Guys, leave that. So this is what we're looking at. So how much did the parents contribute? So remember that for Jack, you guys remember for Jack, they were contributing 200 rands, isn't it? And this was done, they were doing it monthly for 8 years. So we'll calculate what is happening. Then for Peter, they were contributing 800, and they were doing this monthly because the compounding period is monthly. They were doing it every month. And they did it for, no, Jack is 21 years, isn't it, guys? Yep, look at Jack from when he was born. So for Jack, they did this for 21 years. But for Peter, they did this for 9 years, isn't it?
Yes.
So it means when we now look at how much did each set of parent contribute. So we are going to look at Jack's parent. So how much did they put in? So they put in 200 rand every month, 12 for 21 years. How much did Jack's parents put in, guys?
50,400.
50,000 what? 400.
Yes.
And then let's have a look at Peter's parents. So for Peter, the parents were putting 800 rands for him, and they were doing it monthly, but they only did it for 9 years because they started when he was 12. So how much did Peter's parents put in total?
86,400.
It is, can you repeat?
86,400.
86,400. Okay, so that answers question B. Do you guys understand? If you do, give me a thumbs up, and if you don't, just make sure that you do ask. So, thanks for that, guys. Then they say to us, express the percentage of interest earned of the total contribution. So we want to look out how much did we earn versus what we put in. That is what question C is asking us. They say express the interest earned as a percentage of the total contribution. So compared to what we contributed, how much did we get as a percentage more? So it means we need to start looking at the interest gained. So interest earned, remember, it's more like profit. So if we go to C, let's deal with C. So for C, we are looking for interest earned. And I usually look at interest earned as profit. So the interest earned, let's look at P term. So let's start with check. So for check, we want the interest earned or the profit. So what was the total amount that Jack has? So it will be the future value minus this investment here. But let's go and take the future value. So the future value for Jack is 154,000. No, that is Peter. Jack is 170. So let's take that and we will subtract the total amount that the parents of Jack put in. So that will be minus 50,400. So what is the interest that Jack got? Anyone, guys? And while you calculate, let me quickly work out Peter. Just use your calculator. And I'll just fetch that. Will tell me when you are ready. And for Peter, will minus his parents contributed a total of 86,400. So what do we have for Jack, guys? Ayanda,
119,890,05.
like this.
Yes, sir.
Okay. And what about Peter? How much of
60
interest did he get for profit?
67,914,06.
Did you say 67 or 57? Give it a shot again.
67,914,06.
Mm-hmm. So that is what Peter has as interest. But if you read the question, they say express the interest earned as a percentage of the total contribution in each case. So what do you think we should do, guys? We have the actual amounts, but they want us to make it to be a percentage of the total contribution. So what should we do? Yep, you can go ahead. I see a hand from Ayanda.
You're going to take your interest. So for Jack, you'd say 119,890,05. And then you'll divide it by the 170,290,05 and times that by 100 to get your percentage.
Yep, on point. So that is what we need to do. So we have the actual interest, but we want it as a percentage of the total contribution. So we are going to do exactly that. So thanks for that. So if you observe carefully for Jack, the interest as a percentage. So the interest as a percentage, we will take that amount, which is 119,890,05, and divide it by the total or the total amount, which is 170, and then 290,05. So in fact, I'm supposed to multiply this by 100. Anyone, guys, please give us the answer. So I'm supposed to multiply this by 100%.
I'm
What is the
getting
answer?
70.40%.
70.40.
40%.
On point. So that is Jack. So done and dusted. I'm sure Jack is very happy. Let's have a look at Peter's interest. So Peter's interest as a percentage. So that will be the amount or the interest end, which is 76,914,06. And this will be divided by the total amount, which is 154,314,06. So I'll multiply this by 100, and you guys will give me the answer. What do we get?
44.01%.
44.01%. So clearly here, Jack had the bargain. He got 70% interest of the total amount, and Peter only got 44. So 44 is still reasonable, but yeah, this was good. So now that we have this, guys, I need us to think of how can we conclude here. What is the conclusion looking at these numbers? What can we conclude with certainty looking at this, at these numbers? What is our conclusion, which gives us D? What is our conclusion, guys? So essentially, we want to summarize what we see here. So clearly we can see that Peter or Peter's parent they put more money than Jack, but the returns were more on Jack than Peter. And that could be accounted by the number of years and also the interest rate. Let me see. No, maybe not. So let me ask you a question, guys. Between Jack and Peter, I need us to think of what we had done before, actually. Who got okay, yeah. No, Peter got a better interest rate. Okay, there's no question. If you find the effective, you'll find the same because both of them are compounded monthly. So let's quickly write up our conclusion. So if you look at our conclusion, what we first see is that Peter got a better interest rate. Do you guys see? They gave him 12% compared to Jack. You guys see that Peter was given 12% compounded monthly and Jack was given 10% compounded monthly. So that is 1 point. The second point is that we can clearly see that Jack's investment had more time. So essentially all what you are doing, you are just writing what you see here. So Jack's money had more time to stay in the bank compared to obviously Peter. Then what happens at the end? At the end, what we see is that Jack has more profit or more interest at the end. And these are the 3 points that we can list and we get all the marks. Do you guys understand? So I chose 3 points because I saw that we have 3 marks there. Do you guys follow? So they'll say 1 mark, okay, you can clearly see that this one got a better interest rate. However, the other one had more time. But at the end, Jack won, he has more interest. And then they give us the 3 marks that you see highlighted there. Do you guys understand? If you do, give me a thumbs up. Right. I see so many. I see a hand from Ayanda. You can go ahead.
So is it not Jack that has a better interest rate because he had 70.40 while Peter only had 44.01?
So what did I say? I said Peter got a better interest rate. Yeah, no, that is what I wrote is correct. Maybe please repeat your question again.
Okay, wait, so can you please explain how Peter got a better interest rate?
Okay. So you know there's a difference between interest and interest rate. Okay. So if you look at the problem here, do you see that that is why I put in the term rate? Do you see that Jack was given an interest rate of 10 and Peter was given an interest rate of 12? So the rate at which the money of Peter was growing was faster than the rate at which Jack's money is growing. Do you understand? Because both of them are compounded monthly. Does that make sense?
Yes, sir. Thank you.
So Peter was beat by time. So that is why I said Peter got a better interest rate compared to Jack. Rate is very important. It is what we have there. And then I say Jack's investment had more time. So Jack, his money was sitting for 21 years. Peter, his was 9. Then I said at the end, Jack has more interest. Interest is the 70 and the 40. So there's a difference between interest and interest rate. Do you understand?
Yes, sir. Thank you.
Let's go on Monday and school them and say, do you know the difference between interest and interest rate? And when they say you are trying to sound nerdy, just tell them, of course I am nerdy. Any question, guys? Do you understand? Where are my thumbs up? Where are they? Where are they? Where are they? If you're not giving me a thumbs up, it means you are confused. And I should ask you, where exactly am I losing you? Tumelo, what is it which you don't understand?
I understand this.
Awesome. Shaurile, what is it which you don't understand? In fact, I misspelled your name. My apologies. But what is it which you don't understand? Where are others? Okay, awesome. Right, so you guys understand what is going on. That makes me happy. Let me see. Oh, I have just one last example for you guys. Let's ace this. Maths is what? You guys should be screaming.
Beautiful.
Yep. So let's go, guys, and ace this last question, and then we can go now and rest and know that our minds are mathematically aligned. You post and say mathematical mind. We are not the same. Anyway, let's put this as question 7. And then the last question is question 8. I'm so happy because you did all the questions that I had planned. Guys, so proud of you. Let's have a look at question 8. So, any volunteer, guys, please read this for us.
Ricky opened a savings account with a single deposit of 2,000 on 1st April 2018. He then makes 18 monthly deposits of 800 at the end of every month. His first payment is made on the 30th of April 2018 and his last payment on the 30th of September 2019. The account earns interest at 16% per annum compounded monthly. Determine the amount that should be in his account immediately after his last deposit is made, that is September 2019.
Okay, thanks for that. So this is a very pet question, but we are not intimidated. So the first thing that we need to figure out is key terms. And the reason why we need to figure these out is because when you are given a worksheet, the problems will be combined. You'll need to be able to figure out this is a present value, this is a future value. So what is a key term which you guys picked up as you were reading here?
Saving.
Savings.
Savings. What else?
Monthly deposits.
On point. Monthly deposit. So we are done. Monthly deposit. So with these terms, we are done. These terms, all what they scream, they are screaming future value. That is FV. Okay. So with this said, now we need to figure out, guys, what are we looking for here? Anyone?
We're
Determine the
looking for
amount.
the future value.
Okay, so someone is saying we are looking for the future value. Anyone else? Okay, maybe let's put this up as the only thing that is happening. So they say Ricky opened a savings account, the single deposit of 2,000 rands in April 2018. So let's see. April, he makes a deposit of 2,000 rands. And then May, he then starts doing monthly deposits of 18,000. So we need to write a timeline here, guys. Very important. So let's have a look at what is going on. So April, so this is T0, which is April. So he makes a deposit of 2,000 rands. And then T1 comes. And T1 would obviously be May, isn't it? And he makes now deposits of 800 rand. And comes T2, this may be right, comes T2, which would be in June. So in June, he carries on with 800. So he does his 800 for the longest of time now until he gets to the end, which would be after 18 months. So that would be T18. So 18 months later, T18, that is when he makes his last 800. Do you guys understand? And that would be September of the following year. Of the next year. Do you guys understand? So this would be of the next year. Let me see. Is it of the next year even? Yeah, it is. Okay. Does it make sense, guys? Our timeline. He puts in 2000 now. Then the next month, he puts in 800 every month up until he reaches September of 2018. So maybe let's put the year. So this is 2018. And these ones would obviously be 2017. Yep. And this would also be 2017. Yep, and so on. You are 2017. Do you guys understand the timeline? It is very important that you guys react. It's either you understand or you don't, okay? There is no middle. Okay, see many thumbs ups. So done with our timeline. So we now need to think carefully of what happens. Okay. So if you observe carefully, where is this interest rate? Yeah. So if you think carefully of what happens is this year, starting from May up until September of the next month, do we guys agree that this is an annuity? Do we agree? Because that is where he makes the same amount. It's a future value annuity. Where are my thumbs up, guys? Right. But for the other amount, I like maths. It makes so much sense when you give it time. For the other amounts, if you look carefully, where he put in that 2,000, that 2,000 is not going to be an annuity. That 2,000 is just going to sit as a once-off investment up until month number 18. Do you guys agree? So this is just an investment that is once off. So it is a once-off investment. Do you guys agree? He's going to put that 2,000. Has nothing to do with the 800. The 2,000 is aging like wine. So this is a once-off. So it is gaining interest while sitting on the bank, and the other amount is gaining interest as an annuity. Okay. So when we look at our 2,000 rands, let's see. So from April up until September, guys, how many months is that? He makes 18 monthly deposits. So would that be 19? Let me think. So 1, 2, 3. So from April to September, how many months is that? September of next year. What do you get, guys? So April to April, that is 12. And then that's May. And then June, July, August, September. So 12 plus that becomes what? What is it? Anyone, guys? You guys understand my question? So from April up until September, how many months is that? Okay. So I see one from someone, they are saying it is going to be 17. So let me see, April to April, depending whether his pay is made on the 30th of that, and his last payment is made on that. So April to April is 12 months, and then that becomes 17. So there, this 18 here, he makes 18 monthly deposits. Oh, I see what happened. Okay, let's get to this problem, guys. So this person will make 18 deposits in total. So if you think of what is happening is he will make 17 deposits of 800, and then he will make one deposit of 2,000. Does it make sense? So on month number 1, he's going to put in a 2,000 rands, and then followed by an 800, and that makes it to be what you would call 18 deposits. Does it make sense? Okay. So we have two formulas here which we need to use if you think about it. We have a formula which is A, P into 1 plus I divided by M. M times N. This is for our 2,000 Rand investment. Because that one is not, we are not putting monthly deposit. So that one should have the normal compounding formula, our 2,000 Rand investment. Now, our compounding period is the same. So what is our compounding period, guys? When you read the problem, 16% per annum compounded monthly. So our compounding period will be M is 12. Our interest will be I equals 16%. And our P, present value, would be 2,000 Rand for this problem. And we have our M. And all what we need to do here is M times N. For this would just be the number or the time that our money is in there because it's compounded monthly. So what I'm going to do is I'm going to put P or A equals, we are going to have this 2,000 into 1 plus 16% divided by 12. And then remember the period we are given already, that this is going to be, the amount is going to be in there for, if you think carefully, this one is going to be in there for 17 months. So I should put in 17 here. Because from April 30 to September 30, that would be 17 months. Do you guys understand? That money will sit for that amount of time in the bank. I see a hand from Ayanda. You can go ahead.
So since sorry, so for N, since we usually do N as years, how does the formula know that 17 is now months and not years?
Oh, so do you see that actually when we take the compounding period and multiply it by N, we actually getting the number of months or the number of, or the compounding period times, if I can use that. So let me give you an example. So let's say it was 2 years. The N times N would eventually amount to 24 months, isn't it? That is what its purpose is there for. Do you agree? They say 2 years, we need 24 months up there, isn't it? Are you still there?
Yes, sir.
And if they say 3 years and they are saying compounded monthly, what do we need on the exponent? 36. Does it make sense? I said 3 years compounded monthly. We need 36 on the space of M times N. Do you understand?
Yes, sir.
So the point is what sits on the exponent would be the duration that we have the money invested. So in this case, it so happens that it's 17 months. So if you want to convert and find the N, you can easily take the 12 divided by the 17, and then you'll find your N as 1 point something. Do you understand?
Yes, sir. Thank you.
Yep. So anyone, please give me what the A is. What is the A, guys? The amount that would be in the bank as a result of the 2,000. What is it?
2,505.
2,505.
505, 068.
0.068. This seems very small. Okay, that makes sense. And then now let's go for the future value, guys. So the monthly deposits that we are going to make are 800 rands. So this will be into 1 plus. So we have 16% divided by 12, all to the power of. Now let's think carefully. So end of July, or sorry, end of April, we put in 2,000. Then May, we put in the 800. So from May up to September, how many months is that, guys?
4 months.
No, the September of the following year.
Oh, 16 months.
16. Yep. Minus 1 divided by, we divide by 16% divided by 12. What is our future value, guys? The amount which will be due to our annuity, what will it be? So this is September of 2019. So this is 18. What is the future value, guys?
14,163,21.
So you said 40,000?
14,000.
14.
Yes, 14,
Mm.
163,
Comma
21.
21. So that is the future value. So now, guys, we can calculate the total amount which will be in his bank, isn't it? And that total amount will be the summation of the two. So it will be 2,505,068 plus this one here, 14,163,21. What do we get as the answer, guys?
$16,668.27.28.
Like this. Is this correct? On point. I see some thumbs up. So this is what we were expected to do, guys. And yeah, so I hope you are getting a feel of how useful timelines are. So that there at the bottom is our answer. Do you guys understand these concepts? Very nice. And yeah, interesting. Are you guys happy? Hope you are. Give me a thumbs up if you are happy. And if you are not, I need you to make sure that you do ask me more questions. I like explaining. Okay. So if there's no question, guys, for myself, I think we can call it a day. How do you feel about? Okay, let's take a hand from Mashle. You can go ahead and ask.
So,
Yes.
so why did we put 16 on the number of in n times m?
Oh, yeah. So n times m, remember, it represents the, let's call it the period. How many, or remember that the 12 is for our compounding period. So what sits here at the top tells us the total amount of time our money is in the bank. So I made an example, I think, to one of yourselves, and I said, if they say our interest is compounded monthly, and then they say we put the money for 3 years, what do you expect where I have the green circle? What number do you expect? 3 years compounded monthly. What do you expect?
36.
36. So it means because they are saying compounded monthly, 3 years translates to 36 months. You understand? So it means all what we are doing, we are just counting the number of months for the duration that we are given. But here it is nice because they say compounded monthly, but our period is even shorter. So we can just count the months. So if they say compounded monthly for 2 years, how many months is that? Is our money going to be in the bank? 2 years compounded monthly, 24 on point. So in this case, we can put this because they said compounded monthly, and then they said April up until September of the following year. So that is why we can put the actual number of months there. Because we are compounding monthly, we just count the number of months. Do you understand?
Yes.
Awesome. Thanks for the question. Anyone else who has a question, guys? Any closing question? Glad you guys understand. So we're going to pass those annuities questions, especially the future value ones. We are going to ace them. I promise you. So happy to see your thumbs up. Guys, let me see the question that I couldn't do. If I can, I'm not going to do it, but I want to see where is the value that I cut out here. And let me see when I do my cropping. No. Yeah, I'll probably need to deal with this later. So guys, thanks for attending. We did a lot of practice here. It's so impressive. So thanks for attending, guys. I think for now, let's call it a day. The lesson will be up for yourselves to go and review, I think, on YouTube or other platforms. So make sure you do revise. We have done future value here. Next, we will do the present value. And then you would know all what there is to know in financial maths. Isn't it impressive?
Yeah, it
Yeah,
is. Thank you.
it is. So please be in the look on the group for a message as to when are we doing present value. For now, guys, take care of yourselves and have a great night. Maths is what?
Beautiful.
Maths is beautiful.
Awesome. Have a great one, guys. Cheers.